So in this video, let's continue our discussion over factoring and solving trinomial quadratic equations that have a leading coefficient greater than 1. All right, well, on C, we'll notice that we have 60x squared minus 280x minus 100. We just have to factor it. Those numbers are kind of big. So here's what I like to do to start. I could go ahead and factor it as is, but those large numbers are going to be really, really hard to factor with. So I'm going to look for the greatest common factor. And there is a greatest common factor of 20 in everything. So I'm going to take a 20 out of 60, and 20 times 3 will give me 60, so that'll leave me 3x squared. If I take 20 out of 280, that's going to be a negative 14x, and 20 out of 100 is 5. Thinking of, you took $20 bills out of 60, how many do you need? How many $20 bills does it take to get $280? And how many 20s does it take to make 100? Okay. Now that 20 is going to be really important. That's actually going to be one of our factors, okay? So I'm going to use the X method to do the set of parentheses that you see there. So like before, and this time I'll go ahead and list it out. Get a little bit more room. A is 3, B is negative 14, and C is negative 5. So we don't have the directions in front of us this time. So as we do this together, just kind of walk through it with me. Think about what I should do next before I do it. Okay, so I need to take A times C. Well, A times C is negative 15. And the B is negative 14. So I need to find two numbers that multiply to negative 15 that add up to negative 14. Well, to multiply to a negative number, I need a positive and a negative. And I need to think about the factors of 15. Well, to make 15, again, what you can do is off to the side, 1 and 15, and 3 and 5. Those are my only choices. Well, the only way I can get a 14 is to use 1 and 15 and subtract the 2. So, but I need more negatives than positives. So negative 15 will go here, and 1 will go here. Okay, so again, keep in mind that 20 is going to play a part at the end. We're just focusing on this part right here. So we're going to keep the 3x squared. We're going to change negative 14x into positive 1x minus 15x, and then we have the minus 5. So now we look at the first two terms, and we notice that they have an x in common. If we take out an x out of 3x squared, I'm going to have a 3x left. And taking an x out of 1x is just, well, 1. And I didn't really even need to write 1 in front. Out of the negative 15x minus 5, what do they have in common? Well, they're both negative, and they both can be divided by 5. So if I take negative 5 out of negative 15x, that will give me 3x. And if I take negative 5 out of negative 5, that'll give me positive 1. And fortunate enough, the 3x plus 1s are the same. The other factor is going to be x minus 5. Now, if I write that as is, I'm not going to have it correct, because my factors have to multiply back to what I started with. So, and I'll show you what I mean by that. See, if we multiply right now 3x plus 1 and x minus 5, I'm going to get 3x squared, 1x, negative 15x, and negative 5. Okay, look at the boxes and look how nice that is. I mean, it's right there. So that's going to give me 3x squared minus 14x minus 5, which is also right there. But it's not what I started with. See, if I put the 20 in front of that, Now I'm going to multiply out to what I should get. So 20 times that is 60x squared minus 280x minus 100. Therefore, in my factors, that 20 needs to come on down. That's what I'm looking for right there. So your factors need to multiply to what you started with. All right, last thing. The length of a rectangular patio is 4 feet more than its width. If the area of the patio is 140 square feet, what are the dimensions of the rectangle, or the patio, I guess we could say too. Okay. So the area of a rectangle, length times width. Okay, and I've listed the 5 steps out here for you. We need to label the rectangle with algebraic expressions. So we're going to call the width, we'll just call it x. And our first statement says the length is 4 feet more than the width. Well, if the width is x, then we have to be 4 feet more than that. That's going to be x plus 4. Done with step 1. Step 2, write an equation that represents the area of the patio. Okay. Well, area is length times width of a rectangle, so that's going to be x times x plus 4, and that equals 140. And I'm done with step 2. Now, step 3 says write the equation in standard form, set it equal to 0. Okay, so I'm going to first of all distribute the x through. And I need to subtract 140 from both sides, but I can't combine anything. So that leaves me with x squared plus 4x minus 140. And that's step 3. I'm going to need to factor this. Now, there's a couple ways I can factor it. Okay, I can think about it from the box method. Okay, so let's revisit that for one more time here, and then let's look at it from the x method standpoint. So what I would need is I need an x squared, a negative 140, and I need these 2 boxes to be 4x. Now I can do that because this is a 1 here, right? So I know it's going to be x and x. I know it's going to be positive and negative. I have to think of 2 numbers that multiply to negative 140 that add up to 4. Well, let's think. What makes 140? Well, let's try 10 and 14. So 14 would have to go here. 10 would have to go here. How would I know that? Well, the difference between 14 and 10 is 4. And so that's what I'm looking for. Now, if you take a look, did I satisfy the condition? Do negative 14 and 10 add up to 4? The answer is no, they do not. So this is kind of a common thing that might happen to you from time to time. We need to change the signs. And so we'll go ahead and erase and do a little bit of that here. That one right up there needs to change. That needs to be negative, and this one needs to be positive. Now, does it multiply out? Yes. So 14x would go here, and this would be negative 10x. So there are my factors, and I could go ahead and solve it from there, setting both of these equal to 0 and solving. Okay. Now, so that's a way in which we can factor it. Now let's look at the other way we can factor it using this x method, which we actually don't need because it's a 1, but I tell you what, if you're comfortable with it, it'll work every time for you. So my a would be 1, my c would be negative 140, and my middle term is 4. So I'm multiplying the negative 140 and adding up to 4. So 14 and negative 10 I'm going to keep the x squared and put an x with the two numbers that I just found, and then keep the last term. If I factor by grouping, I can take an x out, leaves me x plus 14. I can then take a negative 10 out, leaves me x plus 14 as well. Therefore, my factors are going to be x plus 14 and x minus 10. And there's the solution part. But I have to go back up here because it says solve to determine the appropriate dimensions. Well, we've done that. But if you look at the answers for the width are negative 14 and 10. Well, I can't have a width that's negative. Just like you can't be like a negative height. You have to be a positive height. So that means our width is 10. So this is 10. And if that's 10, 10 plus 4 is 14. And once you know it, 10 times 14 is 140. So the dimensions are 10 feet and 14 feet. And that's how we do that. Okay, that is factoring trinomials. And you'll do more of that in future courses. In fact, you'll do a lot of that in future courses as well. But the power of this is you can problem solve now, and you can solve x squared equations. Now, future videos, you're going to see how to work with x squared equations when they don't factor. But that's to come for another time. Thanks for watching. As always, we'll see you again soon.